In this video, we're going to solve a problem taken from AMC12A 2021. If the roots of the equation x cubed plus ax squared plus bx plus c equals 0 are cosine 2 pi over 7, cosine 4 pi over 7, and cosine 6 pi over 7, then find the value of a, b, c. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. If this cubic equation indeed have these three numbers as their roots, then actually I can factorize the cubic polynomial into x minus cosine 2 pi over 7 multiplied by x minus cosine 4 pi over 7 times x minus cosine 6 pi over 7, and this product equals 0. So these two equations are equivalent. So to find the values of a, b, and c, and hence their product, it is sufficient to find, for example, adding up cosine 2 pi over 7, cosine 4 pi over 7, cosine 6 pi over 7, or multiplying all together, etc. So to do this, we need to kind of do some analysis on what do these values actually represent, these cosine values actually represent. So to do this, let's consider the seventh root of unity. We call this seventh root of unity. So by definition, if I bring it to the power 7, then it equals 1. And of course, this number is not exactly 1. It's kind of another number that represents this kind of relation. Or, to write it in the standard form of complex numbers, it's actually equal to cosine 2 pi over 7 plus sine 2 pi over 7 times I. And in fact, the special thing about this is that if we look at the powers, look at the index and exponent form as an e to the power 2 pi over 7, if I bring this number, I call it omega, to the power n, you will get, in the exponential form, e to the power 2 pi ni over 7. And so if you write that back in the general form of complex numbers, that is cosine of 2n pi over 7 plus sine of 2n pi over 7 times I. So actually, cosine 4 pi over 7, cosine 6 pi over 7 can be very easily be written in terms of cosine 2 pi over 7. And in particular, for this omega, the reciprocal of this number, 1 over omega, is exactly its conjugate. Cosine 2 pi over 7 minus sine of 2 pi over 7 times I. And so from these two equations, or these two expressions, if I add them up, we'll get omega plus 1 over omega equals 2 cosine 2 pi over 7. And so that means I can write cosine 2 pi over 7 as half of this sum. And similarly, I have cosine 4 pi over 7 equals half of, this time replacing this n by 2. So that means it's just half of omega squared plus 1 over omega squared. And similarly, for cosine 6 pi over 7 is equal to half of omega cubed plus 1 over omega cubed. So I've kind of expressed this value of cosines in a more symmetric way. And so now we can say add them up, calculate the products, etc. So in fact, if we expand the polynomial in red and compare coefficient of like terms, you will have a to be equal to minus of cosine 2 pi over 7 plus cosine 4 pi over 7 plus cosine 6 pi over 7. So if I rewrite the value of cosines in terms of omega, I will have minus 1/2 of omega plus 1 over omega plus omega squared plus 1 over omega squared plus omega cubed plus 1 over omega cubed. And if I really add them up into one single fraction, we'll have omega cubed at the bottom, and for the top we will have 1 plus omega squared, and then plus omega to the 4 plus omega to the 5 plus omega to the 6. Now to compute this fraction, notice that if I have omega to the power 7 equals 1, then from this I can say is an equation of omega to the power 7 minus 1 equals 0. And then if I factorize, I will have omega minus 1 multiplied by a power sum of consecutive powers of omega. And since we know that omega is not 1, then this will be crossed out. Or I should use other color. And so that means this power sum is actually equal 0. And for the power sum that we have now, when computing A, with one single term missing, which is omega cubed. So we know that the expression labeled in yellow is actually minus omega cubed. So it's minus 1/2 of omega cubed minus omega cubed over omega cubed. And so that means A is just 1/2. So in fact, these coefficients actually take a very beautiful value. Now let's move on to B and C. Now for B, it's actually I call this pairwise product, as in we pick two of the terms available and then multiply. So then we'll have 3 combinations and we add them up together. So again, I'm going to rewrite them in terms of omega. So because we have 2 terms in each product, so the halves multiply and we have 1/4 of the following. Omega plus 1 over omega times the square version, and then the same expression times the cube version, and then square version times the cube version. So then expand, remove the brackets. I have 1/4 of omega cubed plus omega plus 1 over omega plus 1 over omega cubed, and then omega to the power 4 plus omega squared plus 1 over omega squared plus 1 over omega to the power 4, and then omega to the power 5 plus omega plus 1 over omega plus 1 over omega to the power 5. So to further simplify, notice that these terms, for example, omega to the power 5 and 1 over omega to the power 5, can be rewritten as omega squared plus 1 over omega squared. This is from the fact that omega to the power 7 equals 1. So there's a kind of symmetry happening in these powers. So altogether, I can rewrite into the following. There are two copies of omega plus 1 over plus its reciprocal, and then omega the same on omega squared and the same on omega cubed. And from past experience, we know that when these terms are added together, we actually have -1. So when multiply, we have -1/2. So that's the value of B. Now I can move on to C. So C is just minus of the products of these three values of cosines. And then I'm going to use the same trick. This time we have -1/8 times these sums. And then we remove the brackets again. So this time, I'm going to do it step by step. The first two brackets removed first. And then removing both brackets at last, and another step. So from this, again, we have omega, which is transformed from 1 over omega to the power 6. And then omega to the power 6 can become 1 over omega. This term becomes reciprocal of omega. And then omega squared, or 1 over omega squared. And then similarly, omega cubed from this fraction, and added by 1 over omega cubed. Of course, do not forget the 2. So we have -1/8 of -1 plus 2 from the result we got in part A. And so that means C is just -1 over 8. So our final answer from these three results is that ABC equals 1/2 times -1/2 times -1/8. And our answer is 1 over 32.